Good morning, everyone, and a very welcome to all of you on this cold winter day. It's really great to see such a nice turnout, and I must thank you all for that. Well done to you, Gary, and the science staff that have pulled this together. Now, speaking of Gary, I'd like to introduce him. He has a passion for transforming the mining industry. Gary has built up a global reputation in the mining industry over the past 26 years. And I, for one, enjoy working with him on the Institute. His experience started with various engineering and project management roles within Anglo American, where he has delivered 5 mega capital projects before, and he did this before completing an MBA and co-founding his first business startup, Business Science Corporation. He did this some 14 years ago. This was followed by a tech startup where he focused on next generation technology, and more recently he started up Vuma Collaborations to focus on systems thinking for the mine of the future, and has built the experiential simulation center SciMine at the Mandela Mining Precinct. I've been there. It's well worth a visit. He believes in collaboration with thought leaders globally to bring together the technology, skills, and experience needed to drive a quantum change in the mining industry. And my experience with Gary is that he does walk the talk in this regard. Gary is a registered professional engineer. He's on the Council of the Southern African Institute of Mining Metallurgy, and he's chairman of the SIEM Technical Program Committee, where most of his good work is done. So, Gary, good for you, and over to you.
Great. Thank you very much, Vaughan, for that introduction, and hi, everybody, and welcome. It's cold here in South Africa, and I know we've got a couple of delegates also from overseas, so welcome to all of those as well. Feeling a little bit nervous because, doing a live demo is, people told me during the week I'm either stupid or very brave. So I can feel my heartbeat in my ears a little bit, so I'm not sure which one it is. So we'll see. So I'm not going to do a normal PowerPoint presentation. I want to make this tangible. I'm going to show a real live demo. This is actually a real demo that was used in an actual case study with clients, or in fact in a proper client engagement. I did change the numbers. So it's not the real numbers, but the whole thing is the real value driver tree, and the overall outcome and everything is demonstrated like that. So I do have to start with just one PowerPoint slide. I can't do anything without one slide at least. So I'm going to share my whole screen so I can swap around between different items. So I'm just going to jump quickly here. Right, I've got one slide that I want to show you, and I think the important thing is, a lot of you've heard about value driver trees. A lot of the consulting firms are doing value driver trees in Excel spreadsheets, different software. I've been doing value driver trees since about 2003. I think it's such a valuable tool. I've recently been introducing value driver trees not as a tool sitting on someone's computer, but more as a mainstream ability for us how to change how we do performance management so that it's integrated into the work and management routines of an organization. So it's not just a calculator that's sitting in some corner office that gets used now and then and eventually dies a slow death, but it needs to be integrated into the daily, weekly, and monthly performance management routines of the business, because it's a powerful way of focusing attention. So there's a lot more I want to say as I go through the demo. What I want to show you here is this value driver tree, we've built an overall operational view of this particular opencast operation. We've built a value stream view so we can see the whole value stream, and importantly, we're going to be able to identify where the constraint is. And we've got value driver trees of each one of the individual activities. Now, what's critical about value driver tree, if you want to make it sustainable, we need to build it into the daily, weekly, and monthly routines, as I've said. We've also got to integrate with levels of work. If you have a look at organizations, we're going with these real-time data. We're sitting with operational control rooms, and we've got to start identifying with our levels of work, who's accountable for what metric in the organization, for what time frame, and a value driver to integrate into the levels of work is a great way to drive accountability at the right level. Because there is someone accountable for certain variables within an activity view, someone's accountable for drilling or blasting, and to manage that activity and the key value drivers that are driving the change or variability in performance. So I'm going to jump straight into the value driver tree now. So I'm just going to start sharing my value driver tree. All right. Before I start, the process of actually getting your team on site involved in building a value driver tree, even on a piece of paper, I've actually built value driver trees at a zinc operation where we stuck A4 piece of paper on the boardroom wall and built their value driver tree. That in itself is so powerful because it makes people think about what are the relationship between variables, what are the actual leading indicators that are driving my performance. And it's interesting, often we don't think about what is the output metric we're trying to achieve, what are the things that are impacting, and what are the leading indicators we can actually drive to focus attention. So just that process in itself is so valuable on an operation, and I would recommend that in all your operations. So I'm going to go into this value driver tree. This is, as I said, a real value driver tree. I'm going to first go into a high-level view of this operation and its overall value driver tree of EBITDA. So I've got EBITDA here. Now, this is the particular value of EBITDA for this particular year. So we looked at a one-year value driver tree. You could look at what is important about a value driver tree. It needs a time frame. So it could be by shift. Let's understand what's happening at a shift level. Let's understand what's happening for a day, a week, a month, or a year. This is a particular year. I've got multiple scenarios. So we will show you in a second how you can run scenarios. So what I've got here is actual performance, $634 million of EBITDA. They had a budget of 1.1. It could be a target, budget, aspiration. You could have multiple scenarios. Also importantly, allocating a person responsible for this variable. Okay. So let's start drilling down in this value driver tree. EBITDA is revenue minus cost. Revenue is carats times exchange rate times average price. And importantly, this is a calculator of cost. So all of these variables multiplied together give you the overall top metric. Ore tons, mine core factor, head grade. So what you're going to see here, we didn't achieve our actual performance. We were actually down by 77% on this particular operation. Now, if you have a look at it here, our costs were up 23%. Our revenue was up 54.6%, down 54.6%. So some of it came from cost, some of it came from revenue. Our number of carats was down almost 70%. Our exchange rate was exactly what we expected it to be. In fact, I just used 1 year in this case study. Our average carat price was actually higher. So we were 9% higher in carat price. Our tons were down 66%. Our mine core factor was up 1.1%. And our head grade was up 0.9%. So, there's a whole bunch of different variables that are playing here in this high level view. Now you could start looking at a month, you could look at a shift. So let's have a look here. And this is where a value driver tree becomes important because, historically we're using paper-based reports or PowerPoint presentation with lots of data. I want to see us using value driver trees as the means of having a proper performance discussion with the right people accountable for the right metrics. So there's powerful functionality you can do in a value driver tree, and that is you could go and look at your impact analysis. So I'm going to just jump here to impact analysis, and I'm going to compare what we said we were going to do versus what we actually did. And let's have a look at this. So this is at an overall level. So you'll see here we were supposed to do 1.1 billion of EBITDA. In this particular operation, we only did $634 million of EBITDA. And the question is, well, what caused that variance? Now, we're still at the high-level operational view. We haven't gone down to what we would call sources and causes in the sort of lean methodology. So our average price actually pushed up. All right, I'm sorry, I just want to see, somebody seems to have an audio problem. All good. All right, so everyone else is fine, it looks like. I'm just seeing mine is found. Okay, sorry, I just wanted to check if everyone can still hear me. If anyone can't hear me, just let me know. I can always try and change microphones if need be. All right, so now we want to understand what has actually impacted this operation. So the average selling price was actually up by 10%. So this actually contributed 169 million of additional EBITDA due to carrot price. Our variable cost was actually lower, and you'll see just now that was because we didn't achieve the full production. So that's variable cost driven. So we were down 117 million in EBIT due to variable cost. Now you could, if this was a multinational operation, you could have Forex impact, you could have different price impacts, you could have different regions, and you can start looking, why is my EBITDA being impacted? But this is just one particular operation. So then we've got our processing costs were slightly down. And then we started having items that are actually destroying value. So we did have some positive impact here, but our fixed costs were up. Our head grade was actually down by 0.86%, which had an impact of 14 million on EBITDA. And then the biggest one was our ore tons. So ore tons was the biggest one. So let's drill down a little bit into the value stream view, and let's have a look now of what's actually happening at that view to understand where we can focus. Now, what's important is I'm showing you a mining example, but this is agnostic to industry. We need to be able to model a value stream, model the overall view, and model activities, whether you are in high-tech manufacturing, whether you are making toilet paper, or whether you are mining. I'm just going to see, I've got some comments coming through just to see that everyone can still hear me. Yeah, we can. All right. So I'm now going to move on to the next part of the demo. So we've now looked at this overall view. So I'm going to go through now, and I want to look at the activity view, and I want to talk a little bit about the common metric, because it's such an important point as well that is so critical to understand where your constraint in your system is so that you can focus. So here we've modeled the drilling value driver tree. We've modeled blasting, loading, hauling, crushing, processing, dense medium separation, recovery, and sorting. And each one of them have got their respective value driver tree. So, and I'm not going to use this one as an example, but there's the value driver tree, for example, of drilling with all its output metric and its leading indicators. But I'm going to want to show you something else as well. Now, what's important, the person managing drilling, they manage meters. I mean, you'll see your output metric of drilling is 4.6 million meters drilled for the year. So, in another industry, it might be units produced, or in the case of a converting plant, it might be meters or tons of wadding, as an example. Here we've got blasting in tons, we've got the tons loaded, tons hauled, crushing, we've got our tons treated, our medium separation tons, recovery, and we've got our sorting, all right, which is in carats. Now, what's important here, this is the metric you would use to manage your activity. And the person in charge of drilling is managing it at that level, and they can drill into more detail. But, and here's the big but, is in this operation, it was exactly the same as we find in most operations, and it's not even just in mining. We have lots of stuff we're doing. We have lots of projects, lots of initiatives, and there were things being done across drilling, blasting, loading, hauling, crushing, a lot of projects. I think there were probably over 100. And through this view, you actually don't know where your constraint of your system is, because what's critical here is you need to find your constraint so that you can focus your attention. And this is about resources, this is about money, and importantly, it's headspace of the management team. So we can focus on the constraining activity that will unlock value. Now, in mining, and we're still doing it, unfortunately, and it's not just in mining. And I have engineering firms that come through Simon. we still build balance systems. For some reason, we believe we need to build a balance system so that we can maximize our throughput and we want to minimize our capital expenditure. But if you build a balance system, because of the variability in performance of equipment and of people, and importantly of the actual resource in terms of its characteristics, you end up with, because of that variability, it ends up creating a lot of variability in the performance of the system. And what we know is, dependent and independent variation. Dependent variation means I'm being impacted by my upstream and downstream activities. So that's such a critical thing, that what it does, it impacts the overall performance of the system, which causes a dynamic constraint. As soon as you have a dynamic constraint that's shifting all the time, we need a very, very complex management structure to deal with a shifting constraint, because engineering then are fighting fires across different equipment in terms of availability. Management focus is dealing with constraints at all over the place. And we've got to really design a system with a fixed constraint. And I'll talk a little bit now about how do you exploit a system's throughput by understanding where the constraint is. So I'm going to go back. I'm going to go back to another view that we've built as a team here. And that is something called a common metric. And, there are a lot of methodologies that get used, and there are good parts of every single one of them. No single methodology has everything required to maximize a system performance. You've got lean tools, you've got Six Sigma tools, you've got theory of constraints, and you've got systems thinking. And it's about using the right stuff at the right time to be able to identify, focus, and exploit a constraint to maximize the system performance. And it's not that complicated. And I think that's the key that I'm trying to point out to. We talk about all this real-time data that we're getting. I've been in conferences where we talk about equipment or a truck, and we say it's got terabytes of data per minute that's coming through. Well, you only need a few key metrics, and those metrics are already available. And we can already use what we've got in all our industries to really understand system performance without getting any more real-time data. IR4 is driving even more data, probably creating even more noise, more confusion with regards to decision-making, but we don't even really use what we've currently got, which can add a lot of value to an operation. So, common metric. A common metric is using the same metric across all of the activities so that you can understand what each activity is doing in that common metric. So in this instance, it was tons per minute. Now you'll hear in lean, there's things like takt time, takt rate. Takt time is minutes per unit. Takt rate is units per minute. Basically, it's the concept of takt. You can do it for mining. So in this instance, it was tons per minute. Importantly, taking all the yield losses into account so that it's a comparable common metric comparison. So in the instance of a converting plant, as an example, which we've also done, that could be toilet rolls per second that you apply. Just to give you all a real-time example, if you took the BMW plant here at Roslyn and the X3s, they've set themselves a target of export of 80,000 cars per year, roughly around 80,000. If you took their net available time that they have in the factory of how many shifts they're running and the 80,000, their takt target that they calculate is 4 minutes 20 per X3. Now, everyone says, oh, you can't produce a car in 4 minutes 20. No, that's the exit rate, which is the same as is in this instance, 25 tons per minute. The exit rate is 4 minutes 20. Now you've got to analyze that whole value stream and understand, does that value stream deliver 4 minutes 20 per BMW off that line? And then you've got to look at the different activities. So another example from a zinc operation, and I'm not sure any of that zinc operation here, but MRC tons. It was a target of what the executive sets as the target. If you back calculated it, the MRC tons target was 30 seconds per MRC ton, or 2 tons per minute. That's what that system had to work from mining, all the mining activities, crushing, the mill, flotation, all of that had to be able to achieve on a common metric perspective 2 MRC tons per minute. Anything that's higher than that is the constraint. So in this instance, Drilling can do 25 tons per minute. And now this is the independent throughput. All right, and this is important to understand, and that is, what can this activity do when it's not connected to any other activities? Because that's the challenge we face, is that by connecting activities together, we actually create dependent variation, which limits that activity's ability to produce. So you can't, and it's very easy to calculate. What's its independent capacity? So drilling can do 25 tons an hour. Blasting could do 23.8. Loading could do 22 tons an hour. Hauling could only do 19.6. Crushing could do 21.5. Processing 22. Medium separation 23. Recovery 21. And sorting 21.3. Now, as soon as you put it in a system and you start connecting them, yes, they're going to do less. But if they're operated independently, this is what they could do. So that's a critical starting point. So as you can see in this system, which was very interesting, they never really appreciated that hauling was their constraint. You know, in the dynamics of the system, there are things happening every single day and things are shifting and stockpiles are going to zero. But at this level, hauling at an equilibrium perspective is the constraint. So let's go into hauling and let's go and understand. So if you want to model any activity, you know, there's probably a basic starting point of whether you are in mining, whether you are doing tissue paper, whether you are doing cars. If you want to work out what that activity can do, in this instance, tons hauled, which is 9.2, it's how many hours that activity operates for, and what is its cycle efficiency? How much does it do per hour? So if you're looking at the BMW factory, it's exactly the same. If you look at mining, it's exactly the same. If you look at tissue, it's how long can you run it for and what's your throughput rate? So in this instance, we've called the direct operating hours, truck tons per hour. So let's drill down. Now, the direct operating hours is really your time model. You know, and unfortunately, what I've seen is we make time models very confusing. We have lots and lots of things that people are capturing. The time model really needs to be standardized. You know, building a value driver tree just of your time model and getting a really clear definition of what the different categories are is so valuable in itself. So in this instance, we've got direct operating hours. It's made up of available hours and operational delays. Let's look at what the available time is. It's your calendar time. This is a Contops operation running 24 hours a day, 365. Then it's 43,800 hours. And you've got planned maintenance here of 3,100 hours. This was in the year. Eh? So if you looked at this at the shift level, it will give you your shift-based data. And our unplanned maintenance. So there was unplanned maintenance and our planned maintenance. All right. So there is now, you could break this down into more line items underneath it. So you could do a Pareto on reason for breakdown, which can also be added to the value driver tree. In this instance, we didn't do that. I would always advocate starting from the top down, because you may find metrics that are not that important and you spend a lot of time on them, whereas there may be others that are a lot more critical when you do this analysis. So you start finding the gaps in your data, because you're going to find data gaps. Value driver tree starts helping you understand where the data gaps on the operation, so you can start focusing on closing those. That might be system gaps, maybe business process gaps. All right. So let's look at operational delays. This is quite an important one. Operational delays really are made up of 4 key things. Now, the definition of each of them are really specific to your operation, but you really need these 4 to be able to fully understand a system and be able to understand where its constraint is and what's causing it. So we have a thing called external delays. In our definition, and it does change on different operations, but as long as it's clear, is anything external of the system performance. So fall of ground, electricity, labor unrest, weather delays, those are all seen as external delays. Then we get into internal delays. Internal delays are anything internal to an activity. So now, if you think about it, we've maintained the equipment. So engineering have maintained it, it's available. We now have an internal delay preventing that activity from operating. It could be no operator available, internal delay. It could be a shift change, tea break. You know, often breaks are also logged in here. So that's another example. Training. So anything internal to that activity that's not engineering related are internal delays. And then another two critical delays, and it's badly captured, but it shouldn't be difficult because you only need to capture the instances when it's happening, and that is choking and starving, which is in some organizations consequential downtime. And if you can separate it into choking and starving, what it says is, I'm in activity, so I'm hauling. I've been maintained, so I'm available. I have no external delays. I have no internal delays, but now I go to the loader to load, and the load is down. I've been starved of material. If I can log those hours of being starved, the alternative is I get loaded by the loader. I go to the crusher, and I'm not able to tip because the crusher is down. That would be a choking delay. Now, I'm not talking about the normal cycle times, queuing and that type of thing is actually sitting in cycle time. This is actual delays that are outside of my normal operational cycle. If we can just capture those four. Now, we find in most operations, there's lots and lots of long lists of internal delays and all that kind of stuff. Now, that's fine. People normally capture probably most delays to the top 5, but that's fine. But if you could just group them into these, it starts allowing you to do some really powerful analysis, because that's what we would call categorical data. And categorical data helps for us to understand sources and causes. All right, so that's your time model. All right, in terms of in this case study, I did break down internal delays into 2 other variables, and there were others as well, but this was the main 2. And then let's look at the throughput rate. Now, again, doesn't matter what industries, you can calculate a throughput rate. Even if you're signing home loan approvals for a bank, you can calculate a throughput rate per hour and how many hours you're operating. So throughput rate is tons per hour, which is made up of your average load, number of cycles. Let's go into our average load, and it is fill factor and truck capacity. And number of cycles is made up of our cycle time, which is in queuing, loading, traveling time. Now, if you've got a track and trace system on the mine, this is easy data to capture. It comes out of your fleet management system from a track and trace. If you don't, you just really need your overall cycle time. So if you have a look here, there are actually only 8 key variables you need at a minimum to really understand your fleet and truck performance. And the same applies to all of the activities. So you need your planned and unplanned maintenance. So that's 2. You need your different types of delays. There's another 4. So that's 6. You need your fill factor and you need your cycle time. So that's, and your truck capacity. That's 8 variables, okay? So, you've got all this data coming off the fleet. Now, some of it is what I'd call sort of critical performance data. Other is what maybe it might be called expert data. We do need to differentiate between real performance data versus expert data around, truck engine performance and engineering type data, maybe first class, second class data. So this is all you need to be able to understand performance. Now, what you're going to find is value driver trees should really be used for budgeting, because if you start budgeting actual numbers down here, we will understand real performance of that fleet. Because when do we ever really track or budget what are the actual numbers down here at the leading indicators? Because the leading indicators impact performance of this operation. Now, you'll see here we didn't achieve our tons. We did 9.2. We should have got 15.4. So over this year, what was the most dominant reason? And you can see we're 66% down. Our operating hours were 50% down. Our truck hours were actually our truck tons per hour also down. So we've got 2 things here that are happening. Now, normally in reporting, we look at the variances in each of these, and there's a lot of data and a lot of debate around what is causing it. And you can look at each of the individual leading indicators. But again, let's do an attribution analysis, because we want to know what is the most dominant reason so we can focus. Now, in this particular case study, we built the value driver tree, and then we sat with finance, and we said, here is the operational model. you as finance, what can you control that are your indicators that you can influence overall performance? And we had a discussion with finance. We then went to HR and we did the same thing. Now, what was interesting, and I'm talking about this before I do the next bit of analysis, is the HR, we were with HR head of department plus his team, and the view was, well, there's very little we can do other than we can make sure that the salaries are sorted out, all the admin stuff, all right? And here's a value driver tree, and it's probably the realm of mining and engineering. They understand value driver trees. So we said, okay. We showed him that the constraint in the system was hauling. Here it is. We didn't achieve budget. Yeah, we didn't. Bloody miners never got their tons. So hauling is a constraint. Now let's have a look at the hauling value driver tree. Okay, HR. Yeah, no, that's great. Well, let's now do an attribution analysis. So we go and do an attribution analysis, and we say, okay, so we got our our target. So let's look at our target. And let's look at our actual performance. And all right, Mr. HR department, let's have a look at this. So you're supposed to have done 15.4 million tons in hauling. And it is the constraint. So if you unlock anything in hauling, it is going to improve the performance of this operation. It's simple as that. But you only did 9.2. So let's have a look at it. So in fact, loading times were actually 83% lower. So you actually scored 1.6 million tons in this operation because of loading time. We had less choking than we budgeted, almost 26% less choking, meaning that the crusher didn't choke and it was budgeted. There was a target because there's a reality on the operation. 26% down, which gave us another 800,000 tons of performance. Planned maintenance, we did less planned maintenance, which may not have been a good thing because I think you'll see the unplanned maintenance was higher. So we did less planned maintenance. And then there's a whole bunch of other ones. Okay, so look at this. So our queuing time, we're actually 14% worse than our queuing time for the whole fleet, 380,000 tons. Unplanned maintenance, almost 171% more planned maintenance than when we actually originally budgeted for. We lost 600,000 tons there. Traveling time, 25% worse than traveling time, 2.3 million. And this is real, right? So this number is real. On this particular operation, the biggest reason for non-performance in hauling was no operator available, which, the HR guy goes, oh. So we said, yeah, so HR, is that somewhere you can get involved? And yes, you've got equipment available. There's no other delays, and now you've not got operators. And the HR guys started actually laughing in this instance and said, well, I actually asked the GM to perform, because that actually works out, it's 9,500 hours, which is only 4 operators per month over the year. He said the GM refused to approve the 4 extra operators in the budget because it's going to cost us so much more, and we're having pressure to cut our unit cost. So you see straight away here, we're driving the wrong outcome. We're debating unit cost and cutting budget, but in fact we've destroyed value. And the HR guy straight away was like, now I had his attention, because he said, well, can I justify and prove my budget now and do the business case for every one of my budget line items? Of course you can, because the value driver tree links every decision. So let's run the scenario quickly, because that then indicates to us. So we say, okay, Mr. HR, he said, 4 operators, it costs us not 150,000 Rand a month. Let's have a look at what happens if we'd actually made it 0 and had enough operators. So we run that scenario. All right, so I'm gonna run that scenario. I'm gonna save the scenario. And what I'm going to do here is show you now. So what that does, it obviously reduced our operational delays significantly. It pushed up our direct operating hours almost 50%. And in this instance, and this is what's so crazy, this is a world-class open cast operation, but yet this fundamental was happening because we cut budget and 4 operators. You could have got almost 4 million tons extra, all right, on this particular operation. Just on that, we're talking one focused metric here. We're not talking all the other ones. There's a lot of stuff you can do around cycle times, fill factors, but we're just focusing on one here, which the value driver tree highlighted. And if I went back all the way to EBITDA, just to show you, because this is the crux of it. There's extra cost, yes, 150,000 Rand a month. But what it basically did is it increased our tons, it increased our carats, and our cost did go up, yes. But we went from 634 to 1.1 billion of EBITDA on that one decision, all right? Now the HR guy said, well, can you run me another scenario? Because I've got another case where he said that the finance department had cut his training budget. And because they'd cut his training budget, he had to find a cheaper service provider for training. And because of that, the people spent extra time off site. So there was further training delays impacting our operational delays. And again, that was driven from a budgeting perspective. It actually resulted in almost 360 hours of extra training delay, as you can see it down here. Now, what I want to show you here is if we do an attribution analysis, you can actually see it. So I want to show you here. I'm going to look at the scenario one versus, or sorry, target versus, actual versus target here. Let's just do that. Look at this training. The training was, let's see it, planned loading, training delays, choking, loading. Oh, yeah, we go, training. So I've got this the wrong way around. Let me just change it. So I'm going to look at my target versus my actual. All right, and my training here lost almost 215,000 tons of performance due to training. All right, and that's significant. Now we could run that scenario. So for the HR manager, we said, okay, fine, let's actually run that scenario. Let's make it only 600 hours, which is what the training, original training budget was. We could save that scenario because now he can justify and do the business case for every of the items in his budget. We can go back through to our EBITDA. Right, and it's pushed in. You can't see it. I haven't got enough decimal places. But I think what's important now is now we're actually almost at our target, but there's a lot of other opportunities. So if you have a look at our current our target versus scenario one, which is our scenario we've now run, you can see here we actually exceeding our targets. Right, because we did reduce the tons so significantly. But look at this, we could have also, there's so much more value in our price here, still reduction in value, in improving value because of variable cost. We've still got all tons of opportunity here, mine call factor and head grade. So we can far exceed what our original budget was while focusing on these items. Now, the last comment I want to say before I open up for questions is, the next level of value driver trees is to bring in short and long interval control aspects. We want to get the value driver trees into operations and start using it for proper performance management live to understand real variance in performance. But we want to be able to then bring in control charts, because when you start finding a variable that's not performing, we want to be able to differentiate between common cause variation, which is the variation that happens in a system because of normal common cause variation. It's how the system was designed. It's how people have been trained. It's how the ore impacts performance. So there's what's called common cause variation in control charts, and then special cause variation. We want to be able to manage special cause variation to improve stability, and that needs to be integrated into value driver trees. And then the other aspect is what is termed long interval control or strategic planning, where we need to see the capacity of the operation in terms of simply using a capability histogram to understand what are our targets versus the current performance in a histogram, so that we can start identifying where are the critical things we can focus on to improve the performance in the strategic gap, maybe 1, 2, or 3 years into the future. So that really takes me through to the end. I know I spoke very fast and I covered a lot of material, but I'm hoping that it made sense. I think the takeaways here is we've got to use our current data. We don't need more data. 4R is probably going to generate even more data. A value driver tree, just to build it, focuses people's attention on what are my leading indicators impacting performance. And you don't need that much data. And if you do have data gaps, the value driver tree will help identify those data gaps so that we can basically simplify the complexities of managing a dynamic system. All right. So thank you very much for listening to that. I'm going to stop sharing and I'm going to open up for any questions. If there are any questions, you can actually do it live. I don't know if Camilla can unmute anyone, and otherwise you're more than welcome to ask it as a Q&A and type it in. All right.
Okay.
So thank you very much.
There's a number of questions in the Q&A. I'm not sure if you can see them.
Yes, I can. So I will start answering them. So I will go through them, and if anyone else wants to write down any questions, please feel free to do it. And you can also ask them live if you put your hand up. I'm sure, Camilla, you can unmute them, Camilla?
Yes, Gary, we've got one hand raised. Do you want to do the raised hand first?
Yes, let's do the raised hand first. So, yeah, so if you wouldn't mind, mute them and ask your question.
It's from Dale Namnik. So I'll just allow Dale to speak.
Thanks, Dale. Hi, Dale. Do you want to ask a question?
Hi, Gary. I didn't raise my hand at all, to be honest.
Well, let's go, Dale. That's cool.
I haven't touched my laptop since it started. I mean, I've been watching the screen. It's incredible. So thank you for the invite. I mean, that's some incredible things. So thank you.
All right. No, pleasure, Dale. All right. All right. So Laurence has got a question. Hi, Gary. To visualize the data, can we link the value driver tree to different sources of data, ideally SAP? Yeah, very, very good question, Laurence. Because, you know, to make value driver trees sustainable in operation, got to be able to integrate them into actual daily, weekly work routines so that you're using them every day, because otherwise they're going to die. The second thing is you've got to be able to integrate them to source data. That's a critical aspect. You know, the old days of value driver trees that had to be updated by Excel spreadsheets really meant they weren't sustainable. Value driver trees now can be. This technology has Concerto. What I will do for all of you, I've managed to get Concerto to give me a coupon that will give you 60 days free. So I will send it out to everyone and then you can play. One of the key things is that you can integrate it to any data sources, whether it's Google Cloud, AWS, you can integrate data, and it is a critical aspect to sustainability. All right. Alan King's asked me a question. Thank you, Alan. Is tacting mining the annual volume divided by time, or are you able to be more granular? Great question, Alan. You know, it can be whatever. You know, people say tact time isn't applicable to mining because there's no customer. Well, your customer could be your board. So, or it could be the demand of the market. So you've got to decide what is your target. And then so basically the definition of TACT is net operating time divided by customer demand, or TACT rate, which is more applicable to mining, is customer demand divided by net available time. You can do it for a year, you can do it for a quarter, you can do it for a month. It all depends on the time frame that you are evaluating. In the case of the X3 example I gave you, that was an annual TACT. That was 4 minutes 20 to achieve their annual target, and that's how the factory was designed. So, yeah. Anton Vucht asked me, what data integration methods exist for 2R metrics entered manually? You can integrate to multiple data sources. SAP, Azure, Google, all of them are, there's an API that lets you map to data sources. And again, that's critical. You know, even if there's data that's not correct, my advice is pull the data, get it in a value driver tree. It immediately highlights data inaccuracies. And believe me, if the executive are using the value driver tree for 1 or 2 months, it's going to drive data integrity into the business. Alan King asked me, is OEE a good tool in developing good flows, and how does it affect balance systems? All right, Alan, OEE. OEE, look, and I know OEE has been used a lot now in a lot of our organizations that we're working with. OEE is an ultimate measure of an overall system performance, but it can be dangerous. It doesn't actually indicate often true performance, and I can show you examples where you can maximize OE and actually destroy value. Because OE is made up of 3 components: quality, performance, and utilization. I think those are the 3. It often masks the real reality of what's happening. So in reality, I would rather be measuring the quality, the performance. I mean, if you think about it, it's actually throughput rate, direct operating hours, and quality. Those are the 3 components of OEE. And often the OEE is kind of masked because of multiple inputs that hide it, and we're getting a 63% OEE, and then we're very happy. But do we really know what's happening with availability or with direct operating hours versus throughput rate versus quality? All right, I hope I answered your question. All right, another question from Lorata. I see when you hover on a metric, a text box appears. Can one put comments there? Yeah. So Lorata, you can actually link any data. I didn't show that. You can. The end game really is you want to be able to use it to right-click and say, send a message to someone to say, here's a metric not performing. Here's a control chart. Please, can you reference it? But at the moment, you can attach any document you want to it and write comments in that as well. All right. Anonymous, has this case study been published? Yes. I don't know if it's published in the journal, but if anyone wants to see the case study, I actually did write it up. If you Google value driver tree as a means of integrating activities and departments across a value stream, you will find the full case study, which actually contains even more examples of the discussions we had with engineering and with finance department. All right, great. And Ian Wilbur says, hi, Gary, how's it, Ian? All right, another question from Stephen Ross. Hi, Stephen. How do you take account of interdependencies between different parts of the VDT? For instance, if you decrease the number of operators, how do you take into account the changes in cycle time? There will likely be some added queuing. Okay, so very, very good question, Stephen. I think what's critical here, this is this thing of where does a value driver tree add value and where can it not be used? If you want to simulate a value stream and understand the impact of the interconnectivity of activities, and you're looking at batching, you're looking at stockpiles that are fluctuating, you do need to do a simulation. And what you really need is you need a value driver tree with a simulation, because a value driver, even when you do a simulation, it's a bit like real life. You'll actually battle to understand the dynamics of what's causing variation in your overall simulation output. So you put a value driver tree above it and it starts identifying reason for variance. And it's reason for variance in your simulation, reason for variance in your actual compared to simulation. So a value driver tree gives you a great point in time. You can model all the activities in a value stream, but it won't automatically model the dynamics. There, you've got to use a simulation, but you can quantify the impact it may have and then go into a simulation model. All right. I hope I answered your question, Stephen. I've got another question here from Anton Vucht. In this case study, how does the common metric of tons apply if the process successfully reduces the tons? Okay, good question. You've got to take losses into account. You've got to take the yields and losses into account. So, and that's where the common metric needs a little bit of maths, and it's probably the most complicated part of this whole thing, and that is to be able to convert your common metric so that it's equivalent. So this is how many tons I'm mining of ore, taking losses into account versus what I'm treating in sorting. And that is a little bit of a difficult thing to comprehend, but once you understand how to do it, it's easy to do. So even if you took a converting line and maybe your common metric was toilet rolls per second, you would need to take that from primary and secondary packaging all the way through log cutting, perforations, right through to the backstand and your wadding unrolling, so that every meter of wadding can be back calculated into toilet rolls per second, as an example. So the common metric is critical to being able to identify the constraint. All right. All right, Ian Wilbur's got a question. I'm interested to get an insight into how you derive your common units of measure. Like, how do you derive tons per minute for carrot production, for instance? Yeah, so Ian, and this is where some maths is required. You've got to basically say, this is my carrots, here's my grade, here's my losses that have subsequently happened through each step, so that you can work out the equivalent tons required in that metric, in that activity, to be able to compare it between metrics. That's the crux of it. So it needs a little bit of maths and applying all the losses and everything as well. All right, thanks, Ian. Martin Kramer, thanks for the question. How much extra EBITDA did the company make by spending 150,000 more on people? So, Martin, what was crazy, okay, and this was live, and I won't tell you the mine, and I'm not going to tell you the GM's name, but this is how ludicrous it was. We almost had 600,000 of EBIT extra just by now. Reality is, a mining system is complex. And there's a lot of issues at play, and there's dynamics and other things can happen. You know, Murphy lives on the operation. But to have lost, to have a piece of equipment that cost 20 million rand, and to have maintained it, and to have a mine plan, and then to have it standing because you needed 4 more operators available, is ludicrous. You know, and this is where I could give you examples of big mining operations in this country that have had restructuring, and in the restructuring process, they have retrenched drivers. You know, this is the core engine room of the operation, and we've got to make sure we effectively understand what are the indicators that drive performance. You know, so it is crazy. It is. It was almost 600 million EBITDA in this particular operation. All right, Gary Brown, thanks for the question. Great presentation. What is the plan to build in short interval control and long interval control? All right. If it was up to me, I'll do it immediately, Gary. The challenge is it's not very mature in the industry, and not just in mining. You know, it's the change management behind it. It's not so much the technology. It's how to change people's focus. You know, if you look at short interval control, the problem that we have is any operation has variability in performance. It's inherent. It's common cause variation. It never operates at exactly the same day. But unfortunately, we budget at a number, and then every time we're below the number, we need to explain that variance. So every day we're explaining why we're below budget, or why there's variability in whatever performance it is. Now, the problem is it ends up we are chasing our tails, trying to explain away things, when in reality, all that common cause variation is how the system was designed. You've got to pick up any special cause variation. Now, if you look at control charts, special cause variation is about something that falls 3 standard deviations out of the mean, or maybe it has 7 in a row on each side of the center line. Those are things that are different to common cause variation, and something's causing them, either good or bad, and we need to focus on those. But to change someone's mindset from chasing the red days on a dashboard to ignoring the red days and only focusing on special cause variation is a complete mind shift. And we as management are messing it up, because we're asking for all the reasons for variance, and we're chasing red dots, and all our business reports have got red. If you're red because you're below the budget, now we need to understand why. So it's change management, Gary. The technology, I think, is there to do it. Good. Tim, how do you make sure that there is good quality data being fed into the system? All right, so Tim, a good question. Look, I've done many projects, and you know, data generally has issues, but you need to use the data in a value driver tree and start using it in decision making, because it will quickly expose issues and will drive the data being fixed up. I mean, you need the GM only to use the value driver tree for 1 or 2 months, and it's going to drive integrity of data. Also, you know, we don't need detailed metrics, and that's why we call it the Woodstock principle, because in Woodstock in 1968, we always said people wanted to stay as high for as long as possible, and that's the whole thing. If you build a value driver tree, even if you have variables that are placeholders, plot or load what data you have, because it will identify where your gaps are in data that you may need, and where you may need to fix up data. All right. Question from Lorato. What are the high-level learnings from the adoption rate point of view based on areas we have implemented value driver trees? Biggest learning. integrated into daily, weekly routines. Otherwise, the value driver tree is going to get dust on some corner person's office. It's not just for BI as a tool. It should be used as a performance management tool integrated into how you operate the business, and it must be integrated into source data. If every operation has enough data to build a version 1 value driver tree. Start there, build the maturity, and build it down and start at the top. Even as an example, just build a value driver tree of your time model. Just build your time model value driver tree, and let's start understanding the time model across activities. Okay. Another question from Ian. Thank you, Ian. How do you decide what data is relevant out of all the data typical accumulate? Okay. Build a value driver tree first. Understand your metrics. Then start understanding which metrics are the biggest that are impacting your performance. And you may need to go into more detail there, or you may need to say, well, we need more data here, we don't have it. We may need to actually close those gaps with different data systems and maybe a project to close the gap. But start high level and use the value driver tree to identify which variables are critical to performance. All right. Got a question from Takani. I'm currently using a business structure performance model for business improvement. Your presentation helped me understand how your delays to run scenarios. You please advise reading material or reference that can help understand the use of VDTs in detail. What I would recommend to go on Google, and even if you email me, you can get my email address, I think, off the internet, or email Camilla. I will send you the case study. It went into a lot of detail. It showed you how you build a value driver tree. It showed you how you use a value driver tree. And I've got a lot of other material I'm more than willing to share with you. All right. And here's George Craft. Hello, George, one of my ex-teammates. How difficult is to use the software? What is it called? George, it's easy. It's called Concerto, cloud-based software, and it's software as a service. All right, Michael Fox Martin. Hi, Gary. Please describe your experience, recommendations in deriving a common metric for development or waste stripping. Okay. It's easy to do, Michael. I have done it. It's a critical thing that I think is missing in mining, and this is why we end up mining ourselves into a corner. Because if you think about it, a common metric must go right from topsoil stripping through to waste stripping, and whether you're doing development, footwall drive, breakaways, crosscuts, stoping ends, you need to have a common metric right through the whole process. Because if any one of those are not in sync, you're going to mine yourself into a corner. So even if stoping is 1 meter per month more than your rest of your system can accommodate, you're eventually going to run out of faith. So this really needs to apply underground, open cast, right from the starting point. So if it is an underground scatterbreast mining method, you've actually got to link footwall drive development to your breakaways, to your crosscuts, to your raise lines, so that you understand the whole thing right through. All right. Navade, I hope I said that correctly. Thanks for this informative demo. I wanted to know the contribution of services that do not directly contribute to production, i.e. rock, mechanics, ventilation. It seems your focus was more, okay. So you can build a value driver tree of anything. I focused on production because, the core around performance is fundamentally around production. But yes, you can build those in as long as you can quantify the impact they have. And it's very similar to the earlier question around development ends. If you could link your development end common metric to some of the key variables around survey, rock engineering, then they will expose it. Just out of interest, I built a value driver tree many, many years ago. George Craft will know this, where I built a value driver tree of actually the consulting business, right down to all the leading indicators. And my tea lady at the time, and Lindiwe, she unfortunately passed away now from pneumonia. I'm really sad. But we brought her in and said, now, as the tea lady, let's have a discussion with how do you impact some of these leading indicators? And we demonstrated that there are critical leading indicators here around staff happiness, around people being under pressure, about clients walking into the office, around project rollover of projects, people's ability to deliver under stress, and it changed her life forever. It was incredible. All right, I hope that answered your question. Yes, you want to access the VDT to Playwright? Yeah, you're more than welcome to. I will send everyone that was on this webinar, I'll just mail out a little coupon code that will give you 60 days. And I've got 2 example value driver trees that you can actually access there. One is the EBITDA model, so that you can play on the EBITDA model. And I also have put on there the hoarding model, so you can play with the hoarding model as well. And then please feel free to reach out to me if you need any assistance at all. Hey? Peter Smith, thank you, Gary. Do you see more value in bringing this capability closer to the OT space for more real-time data enabled short interval, or would it be? No, I think it needs to be brought into the OT space. I think value driver trees, and this is where I think it's valuable, is if you look at a shift level and you want to know, if you look at fleet management, you can watch on a live screen all the trucks running around. But at any instance in time, a truck might be stopped here, this one's loading, this one's tipping, this one's moving. But if you progressively are plotting a value driver tree for hauling during the shift and for the shift, and then day to so shift to date, shift day, you could start picking up the most dominant reason for not achieving the fleet throughput, and then you could right click on that variable and look at a control chart and see, here was a special cause. Now let's understand a special cause. Now really where it should go to is, you've now got a point of time where you've got a special cause. If you've got all those cameras around the pit, you could almost look at a video of that instance on a control chart. So imagine clicking on a control chart, special cause variation, right click and say view video, if there are videos around the pit. So I think there's some quite amazing stuff that could be done there. All right, question from Andrew Ely. So yeah, thank you, Andrew. Yes, it can basically connect, just so everyone knows, he's just reiterating, it can connect any data sources that you need. So as long as you've mapped your variables to your data source. All right. Question from Alette van der Venter. Do you utilize the value driver trees with mineral resource throughput management? Yeah, most definitely you can. You can model anything. You can model safety. I've modeled safety in the past. I actually been modeling a rapid operational improvement project in the moment where it gave a great view of what are the levers that we can do for rapid operational improvement. Heath, hi Gary, have you seen this approach including metrics around all body performance, e.g. expediting modeling reserves versus actual mine, sometimes called mining efficiency, that is a measure of mining loss and dilution? Yes, I actually built a conceptual version of that, Heath, many years ago for an underground mining operation, where I was trying to get people to understand when there was a head grade variance, what was causing the head grade variance, right down to the ore body model. So most definitely can. It's just a mathematical model, and it all depends on how we can conceptualize how to do it. All right. Dr. Urashani, Governor, hi, Urashani. Gary, great insight. Thanks. Was the data collated, extracted from the site, connecting to operating systems via an API? So in this instance, this particular model, just so you know, we pulled the data manually because this was part of an operational improvement project for this particular operation. So it wasn't actually to integrate a live value driver tree into this particular operation. We pulled the data manually out of the systems. So in this instance, we just loaded it into Excel. All right. Oliver, hi Gary, how long did it take you to build the full model? The value driver tree modeling is easy. It's not difficult to do. It's quick to do. There are 2 pieces that take a little bit longer. And again, through my experience, it can be streamlined a lot. One is you've got to engage the operations to build their own value driver trees. That's just so valuable. You could have workshops to understand the value stream, do a value stream mapping workshop, do a workshop for each of the activities, maybe 2 hours initially just to build it. The value driver tree, then building that is easy. The integration might be challenging, So, and when I say challenging, it's not as challenging anymore. The API makes it easier. There's a bit of data discovery to find out where you can find the relevant variables. So it's not that difficult anymore. All right, Mohsen, I was wondering, what is your opinion on linking value driver trees to system dynamics models, system dynamics, as opposed to systems dynamic simulation, which covers a short-term interval simulation dynamics of the process at a longer-term time interval, which might be easier to link? Yeah, look, I think we need to integrate it. I was doing some work with Siemens using Technomatic, and the challenge is you can build a simulation model and you can run all these different scenarios, a discrete event simulation model. And interestingly, then you get all these different results and you don't know why, what drove the different outcomes, because, it's dynamic, just like any organization. And you could put a value driver tree above a simulation model. So whether it's the simulation pumping out key metrics into value driver tree or its actual operations, you can then try and understand reasonable variance between two different simulations or between the simulation and actual. So it's definitely something that needs to be done. Right. How does the functionality and user-friendliness of Concerto compare to at risk? I don't know. I didn't realize at risk could do value driver trees. I'm actually going to go check that out and see. I've never used that risk for value driver trees. So it's an interesting question, which I can't answer right now. And Gartha, how's it, man? If I were to build a value driver tree in underground mining, would it be fine to normalize all the mining cycles to time, calculating tons per cycle, and then link that up to the business process to normalize tons as a pro? I think I understand what you're saying. You need to create a common metric. So, pop me a mail. Hey, we can have a quick call and I'll chat about it. It's about building the common metric and understanding the value stream and having the right time frame. So you might want to look at it per shift or per hour. So I can help you there. Right. So I see someone shared the technical papers. So thank you. Martin's got a question. How many saving mining companies have adopted the value driver concept? So Martin, it's interesting. I mean, there's been a lot of value driver trees built. A lot of them in Excel, not integrated. So they've generally been the world of the BI, business improvement department, as a tool. I don't think there's a zinc operation that I've been working on recently. We worked with GE, and instead of building traditional dashboards off their historian database, that would have been the normal approach, we basically built a value driver tree from the top to the bottom of the operation, right down to value stream. We even modeled the filter press. So we had the MRC tons produced per shift. So we modeled the whole thing. That's the real only first one that I've seen that's actually using value driver trees as operational performance. So I think it's a big opportunity. It needs a mindset shift. And this is really what I'm trying to push now with this case study, is to show everyone the opportunities of how we can now change the way we do performance management. Another anonymous again, Gary, we are playing with large numbers of scenarios and Excel is a nightmare. Does Concerto handle? Yeah, you can generate whatever scenarios you want to. So that's the great thing. You can compare all scenarios and you can then compare them. So you could compare scenarios. If one is minus 100 billion and 100 million, the other one's positive 1 billion. Let's say you can project valuation. You want to know why? You do attribution analysis. This says, well, did you know these are the variables and how they're comparing the two scenarios and what's attributing the delta in performance. Anonymous, can you talk to how benchmarking data has been used in a VET model comparing operational? Yeah, so you could create benchmark and it all depends on how you're talking about benchmark. If you're talking about benchmark as data you gathered from the industry or maybe other operations or best demonstrated performance, you could just make it a scenario. So you could actually create a value driver tree, put your actual performance in, put in a benchmark scenario, and then you right click on attribution and it'll tell you how every variable is comparing to your actual and how it's impacting your output variable. Martin Kramer, in one paragraph, why should mining companies use value? Okay, in one sentence, Martin, it's about creating focus so that you are impacting your leading indicators that are changing, that are impacting performance of the operation. Because fundamentally, you're trying to maximize the performance. You want to focus on the right areas, on the right leading indicators. Because we unfortunately are chasing too many initiatives and too many things that are not actually generating value. I'll give you a good example from something I did in Australia a few years ago, where I presented to a whole bunch of PhDs and they were doing incredible work. And the head of this institute asked me to come and do a presentation to try and explain to all these guys that it's about the system. And after I explained about systems thinking and about value streams and finding where you're constraining a system, one of the PhDs came back to me and said, I now understand it. He said, I was doing this incredible mill project and I was able to improve mill throughput by 10%, and I was putting automated process control, and the client was telling me I wasn't adding any value. And he says, I understand it now because the mill wasn't a constraint. You can do whatever you want to milling. If it's not the system constraint, you won't generate a single extra ounce of material out of the system. Louis Bardenels, can Concerto Analytics deployed as an on-site installation? Can it be? Yeah, can. So you can create your own tenant. So you don't have to be on the cloud. You can run your own tenant, which is set up for yourselves. And there's enterprise licensing, and then you can connect to MS SQL as well. All right. Anonymous, does Concerto allow risk-adjusted modeling and risk simulation? Yes, it does. It would allow you to play with different scenarios and put in different variables and then run different scenarios between certain set limits. So you can do that. Constraint modeling is really important. Does Concerto allow constraint modeling of models? Yes, you can put it in constraint mode on and off, and you can run it constrained or unconstrained. Again, it's just how you build the model. And I think the key is the common metric so that you understand where your real constraint is. All right. There are a few questions under chat, which I'm going to just see. I don't know how many people are still online, but I'm going to sort of quickly run through the chat. I'm happy to carry on talking. Anyone who wants to stick online, I know we're kind of over time, but I'm just going to run through these chat questions quickly. Sorry, I'm just filming. Can link to different data sources? Yes. So let's see if there's any others. Okay. Okay, I see all the same questions. One of the major issues in underground mining is collecting info for each of the processes. I know Sandvik and Epiroc are doing a lot of good work in the space. Could this still be used to theoretically determine which levers to focus on the system? And then time studies? Yeah, no, for sure. Building the value driver tree so everyone understands what your leading indicators are. I've been in operations where, the team are debating, is this impacting throughput or direct operating hours? And there's a confusion around what metrics impacting what. Just build a value driver tree. It's a great way for people to understand it. And you could actually go underground and do time studies with a stopwatch to start understanding some of the critical levers that are impacting performance. So yeah, it doesn't have to be real-time data. Yeah, we will share the video with everyone. Simon will put this video onto the website, and I can share the case study with anyone who would like it as well. All right. Okay, I think we've covered all of them.
Gary?
All right. Cool.
Gary, there are two questions that popped up in the Q&A.
Okay. All right. So Martin wants to know what would be the best headline to me to communicate the story. I'm an engineer. Martin said, I think engineering. I'm not a good headlines guy, but thinking about something around swamped with data, starved of insight, in the mining industry, too much data noise, focus, attention, those are the key things that this is around, focusing on what really matters, driving performance through focused attention. This is what we're trying to achieve in the industry. All right. And yes, there's a question here from Anonymous. Yeah, there are traffic lights as well, so you can start seeing what are the variances and all of that kind of thing. All right. Good. I went through every question. I feel exhausted. So I don't know if there are any other questions. Otherwise, thank you very much for anybody. If anyone wants to ask a live question, they can quickly put up their hand if there are any further questions from anyone. And I'm more than happy to answer, or you can mail me. I'm passionate about value driver trees. I just want to help. So if anyone wants to build value driver trees, you know, and they've got some questions, they're more than welcome to mail me. I'll put in the effort and the time to answer anything. So thank you very much. I see 2 more Q&A questions just arrived again. Yeah, thank you, Martin. I hope I did your headline justice. And good. All right. Well, thank you, everybody. I really appreciate everybody attending. I really appreciate all the questions. I mean, people really thought through the questions well. So I'm very, very chuffed about that. So that's great. It makes it feel worthwhile. So good. Right, and everyone have a good day. And please stay safe with all the nonsense that's happening in our country. So please all stay safe and take care. All right.
Thank you, Gary. Bye.
Thank you.
Thank you, everybody. Bye.